this YouTube channel and hit the notification bell to get updated each time we upload a video. So today we'll be looking at implicit derivatives. Alright, for instance, you are given this function to differentiate implicitly. So what we are going to do here is we are going to differentiate this function, and each time we differentiate y, we will put dy dx. We'll differentiate x, but each time we differentiate y, we will put dy dx beside it. So like in this example now, in this question, let's check. When you have xy equal to 1, differentiating x, you are going to have y plus differentiating y, now we are going to have x dy dx equal to 0. Remember, to differentiate 1 here, we are going to have 0. So now we'll now bring this y to the right hand side. Bring this y to the right hand side. So if you do that, we're going to have x dy dx equal to minus y. Alright, so now we are going to find dy dx. That means we're going to make dy dx a result of the formula. So we are going to take this x to this side. So that is going to give us minus y over x. So this is your dy dx. So let's look at example 2. Let's look at the second example. Let's look at this, your dy dx. Let's look at the second example where you have 2x square y equal 3. So 2x square y equal 3. What we are going to do here, we are going to differentiate this, keep this, and differentiate this, keep this. So let's differentiate this first. So differentiate 2x square, we are going to have 4x. We are going to have y here. Then this is going to be plus. You now keep this. Differentiating y now, we are going to have 2x square dy dx, which is going to be equal to 3, because if we differentiate 3 here, we are going to have 0. So now we'll still collect like terms. We'll take this to this other side, to the right hand side. So that means we are going to have 2x squared dy dx is going to be equal to minus 4xy. So making dy dx the solve of the formula here, dy dx is going to be equal to minus 4xy divided by 2x squared. So breaking this down now, you are going to have this square here will go with 1x here. You are going to have minus 4y divided by 2x, and this will also break down to this 4 will go with 2 here. You have minus 2y over x. So this is your dy dx. So let's look at the third example. Let's look at the third example. Y is equal to ax squared plus xy minus 3y squared. Let's solve this example now. So now bringing this y to this side now, let's bring this y, let's take this y to this side and equal this equation to 0. We are going to have ax squared plus xy minus 3y squared minus y equal to 0. So now let's differentiate this properly. This is going to give you 2ax plus, differentiating this now, we are going to have y plus x dy dx minus 6y dy dx minus y dx equal to 0. So that differentiate this, you have y minus y dx. Differentiate this, you are going to have 6y dy dx. So let's call it like terms then. We are going to have x minus 6y minus 1 go into bracket of dy dx equal to let's take this one outside here, equal to minus 2ax minus y. So the y dx is going to be equal to minus 2ax plus y. We'll factorize minus outside, all divided by x minus 6y minus 1. So that means we take this one as denominator, divide it outside by this. So this is your dy dx. Let's look at example 4. Sin y plus cos x minus xy squared plus 2y plus x sin y. So let's solve this using implicit derivative. Let's solve this. So in solving this now, I'm going to employ a shortcut method here. I'm going to show you a shortcut method here. So where you are going to differentiate the x over the y, this is what we are going to use. We'll differentiate the numerator with dx with respect to x, then partially with respect to x, and we'll differentiate the denominator partially with respect to y. So this is going to give us, thus differentiating this function here partially with respect to x as a numerator, are going to have 12x. Are going to have 12x sin y minus sin x minus y squared plus sin y, all divide. We are going to put minus outside the bracket. Put minus outside the bracket. All divided by differentiating partially this same expression here with respect to y. So if you do that here, we are going to have 6x squared cos y minus 2x y plus y, plus 2, that is differentiating this. We have plus 2 plus x cos y. So this is your answer. This is your answer. So but then let's use the long method and compare it and see if we have the same thing. Now let's differentiate this here. We are going to have 12x sin y plus differentiate sin y. Now we are going to have 6a squared cos y dy dx. Remember, if you differentiate anything with respect to y, you are going to put dy dx, and this plus differentiate this. Now we are going to have this will give you minus, cos y, minus sin y, minus sin y. So we have seen the shortcut method of doing that. So let's look at the longer method now, the main method we have been using. Now this is our example 4, where we had 6x squared sin y plus cos x minus xy squared plus 2y plus x sin y. So now let's use the longer method of doing this as we have been doing before, and see, compare it with our shortcut if we get the same thing. So differentiating this one with respect to x and y. So this is going to give us 12x sin y plus 6x squared plus y dy dx. Remember, if you differentiate with respect to y, you put dy dx plus. So this is going to give us minus, because we have this will give us minus here. So this will be minus sin x, and this is minus y squared minus 2xy dy dx plus 2 dy dx plus sin y plus x cos y dy dx. Let's put this to be equal to 0. So this is what we have. So now let's break this down. Let's take the terms with dy dx one side and the others at the other side. You have 6x squared cos y dy dx minus 2xy dy dx plus 2 dy dx plus x cos y dy dx to be equal to, take this to the other side, take this to the other side, take this to the other side, take this to the other side. You're going to have minus 12x sin y plus sin x plus y squared plus sin y. So now let's factorize. We're going to have 6x squared cos y minus 2xy plus 2 plus x cos y into the bracket of dy dx. It is going to give equal to, let's bring minus outside there. From this side, let's bring minus outside. We have minus 12x sin y minus sin x minus y squared minus sin y. This come to this side supposed to be minus, so you are supposed to have minus here. Then there is the box. This come to this side supposed to have minus here. The sin x, this one is correct. Then y squared, this one is correct. Okay. So now this is going to give you plus here now. This will give you plus the bracket. So the next thing you have here is to divide both sides by 6x squared cos y minus 2xy plus 2 plus x cos y divided by 6x squared cos y minus 2xy plus 2 plus x cos y. So cancel these out. You have the y dx to be equal to minus 12x sin y minus sin x minus y squared plus sin y, all divided by 6x squared cos y minus 2xy plus 2 plus x plus y. So let's compare this answer with the one we had. You discover that they are the same. Compare this answer with the one we had initially, you discover that they are the same. So let's look at our fifth example. Let's look at our fifth example where you are given x squared plus y squared equal to 2xy. So now this is going to give you x squared plus y squared. Let's take this to this side. We're going to have minus 2xy equal to 0. So let's now work on this properly now. Using our shortcut method, minus the x over the y. This is going to give us this. Now differentiating this, the function, this expression with respect to x, this is going to give you 2x. Remember there is a minus outside here. 2x. Then this will be minus. Differentiating this now with respect to x, we are going to have 2y all over. Let's differentiate with respect to y. Differentiate y squared with respect to y. You have 2y minus differentiate 2xy with respect to y. You are going to have minus 2x. So this is what we have. So this is going to break down to minus 2 into x minus y divided by 2 into y minus x. This will go with this. So this is going to be minus x minus y divided by y minus x. So this is the y dx. So let's use the long method now and see what we are going to have. We're going to differentiate all of this now. We have 2x plus 2y in y dx minus, differentiating this now, we have 2y minus 2x in y dx equal to 0. So we have 2y in y dx minus 2x in y dx equal to, take this one and this one to the other side, we have 2y minus 2x. So now 2y minus 2x, the bracket of the y dx is going to be equal to 2y minus 2x. So this is going to give you, let's take it here, this is going to give you the y dx will be equal to 2y minus 2x divided by 2y minus 2x. So this is going to be equal to, this is 2y minus 2x, this is 2y minus x into 2y minus x. So this is going to give you 1. Now let's also look at this now. This can also give us 1 because this, the numerator here, it's having minus outside. So let's open the bracket of minus x plus y divided by y minus x, which is the same thing as y minus x divided by y minus x, which is equal to 1. So you can see that this and this are the same. So that is it for implicit derivative. Please subscribe to this YouTube channel and hit the notification bell to get updated each time we upload a video. Thank you.